The topic which we are going to see is the electromagnetic wave equation. That is, we are going to derive the electromagnetic wave equation from Maxwell's wave equation. We all know about that. We have studied in our from a plus 2, that is in the chapter of electromagnetic wave equation. We have studied the Maxwell's equation, that is 4 Maxwell's equation, Gauss law in terms of electric field. From the Gauss law, we have derived the Maxwell's equation, del vector dot d vector is equal to rho. This is a differential form, and we have another form called as integral form also. But mostly we will be using the differential form for the deriving an electromagnetic wave equation. And then second law is based on the Gauss law in a magnetic field, that is del vector dot b vector is equal to 0. This was the second Maxwell's equation. The third one is from the Faraday's law, that is del cross E vector is equal to minus dou B vector by dou T vector. And fourth one is based on the Ampere's law. Ampere's law, that is del cross H vector is equal to J vector plus dou D vector by dou T. So these are all the four Maxwell's wave equation, which is we are going to use it to derive the electromagnetic wave equation. So generally electromagnetic wave equation are derived from Maxwell's equation. Here we are considering a medium. That medium is a homogeneous. It is made up of a single medium, and then that medium contains permittivity, that is as epsilon, permeability mu, and then conductivity sigma, and charge density. In that the charge density on that material is rho is equal to 0. These are all the things which we are going to consider. That is, we have considered a homogeneous medium. A homogeneous medium, that is a material made up of a single medium. That medium's permittivity is taken as, what is meant by permittivity? That is penetration of magnetic field, electric field into a material, that is called permittivity. What is permeability? That is measure of penetration of magnetic field into a material, that is called permeability. And electrical conductivity, we all know that, and that is a sigma. Charge density is the number of charges per unit volume, that is called a charge density. Charge density is equal to 0. So these are all the things which we are going to consider, and we are going to apply these concepts in the Maxwell's equation. So the Maxwell's equation, first equation is del vector cross dot d vector is equal to rho, and d dot b vector is equal to 0. That is second equation. Third equation, del cross E vector is equal to minus dou b vector by dou t. And fourth one, del cross H vector is equal to J vector plus dou d vector by dou t. So this Maxwell equation becomes as that is, since we have considered permeability as mu, permittivity as epsilon, and conductivity as sigma, and charge density as 0. So based on this, we are going to consider some relation, that is J vector is equal to sigma E vector. These are all the basic formulas which we have learned. D vector is equal to displacement vector. D is equal to epsilon E vector, and B vector is equal to mu into H vector, or H is equal to B vector by mu, and rho is equal to 0. Considering these terms, the Maxwell's 4 equation is changed as del vector dot D. What is D? D is equal to epsilon E vector, and is equal to rho. What is the value of rho? Rho is equal to 0. And then del dot E, that is, we can bring this epsilon to the another side. When we bring this, 0 divided by epsilon will become 0, and del vector dot E vector is equal to 0. This was the first equation. Then there is no change in the second equation. Del dot B vector is equal to 0. And fourth also there is no change. That is del vector cross E vector is equal to B minus dou B vector by dou t, and del vector cross H vector is equal to J vector plus dou d by dou t. So this equation changes to, now we are going to see how it changes. Instead of H is equal to B by mu, and instead of J it is equal to sigma E, and instead of D we can substitute what? Epsilon E. When you substitute all this value in this fourth equation, the fourth equation becomes as, that is del vector, this is the first equation. First equation is del vector dot epsilon E vector is equal to 0, or del dot E is equal to 0. So in the fourth equation, del cross H vector. What is the H vector value? B by mu. So here del cross B by mu is equal to J vector. J vector. What is the value of J vector? J vector is sigma E, and dou d by dou t. So instead of d we are substituting epsilon E. So in this equation here del vector cross B vector, and we can bring this mu vector to your right hand side. So mu of sigma E vector plus epsilon into, we can bring this epsilon outside. So epsilon into dou E vector by dou t. So when we bring this mu inside, it becomes as what? Sigma mu epsilon E vector plus epsilon mu dou E by dou t. This is the equation. Fourth equation changes to this format. And then by these equations, that is by the equation number 1, this was our first equation, and this was our second equation, and this was our third equation, and this will be our fourth equation. Based on these four equations, now we are going to derive the electromagnetic waves in terms of electric field. So what we are considering the equation 3. What was our equation 3? Del dot E vector is equal to minus dou B vector by dou t. So this equation becomes, and the third equation we are taking curl. I think we all know what is a curl. Curl is a del cross del vector cross A vector. If it becomes a curl of A. Otherwise, if it is del vector dot A vector, now it is dot A. It is called as dot A. This is the difference between curl and A. So taking curl on both the side of equation 3 means del cross E vector is equal to del cross of minus dou B by dou t. So here del cross E is equal to, we can bring this dou by dou t outside. So when we bring this outside, it becomes dou by dou t of del vector cross B vector. So we are bringing this term outside the del cross. So when we bring this, it becomes as dou by dou t of del cross B. So what is the value of del cross B? We have derived this in the equation 4. What is del cross B? Is equal to sigma mu E vector plus epsilon mu dou E by dou t. This was equation 4. This equation we are going to substitute in the equation 5. So del cross E vector is equal to minus dou by dou t of, what is del cross B? Sigma mu E vector plus epsilon mu dou E by dou t. So when we bring this dou by dou t inside, it becomes as what? Del cross E vector is equal to minus sigma mu into dou E by dou t minus epsilon mu into dou square E by dou t square. So we are using a vector identity. When we use a vector identity, del vector cross E vector, it is will be studied in our vector calculus chapter. So del dot E minus del cross E vector. This is the formula for del cross E vector. So del cross E vector is equal to del vector of del dot E vector minus del square E vector. Okay, this is the formula. So we can substitute this 7th equation in 6th equation. We are going to substitute in a 6th equation. So here becomes del dot E minus del square E vector is equal to minus sigma mu into dou E by dou t minus epsilon mu into dou E by dou t. So here we all know that del dot E is equal to what? del dot E is equal to 0. So this term will become 0. Del vector of 0 minus del square E vector is equal to minus sigma mu dou E by dou T minus epsilon mu dou square E by dou T square. So here we have this term will become 0. Here this one will be, when we cancel the subtraction on both the side, this term and this term, all the subtraction will get cancelled and we may get a positive term, that is del cross E vector is equal to sigma mu dou E by dou T plus epsilon mu dou square E by dou T square. So we can bring all the right hand side terms to the left hand side. So it becomes del square E vector minus sigma mu dou E by dou T minus epsilon mu dou square E by dou T square is equal to 0. So this was the electromagnetic wave equation in terms of electric field. Next, similarly, we are going to derive the wave equation in terms of magnetic field. So we have a fourth equation. What is our fourth equation? Del cross B vector is equal to sigma mu E vector plus epsilon mu dou E by dou T. So taking curl on both the side, when we apply a curl on both the side, it becomes del vector cross of del vector B vector is equal to, del cross E vector. These two terms are constant, so we no need to take inside a del dot or cross. So sigma mu and plus dou by dou T of del cross E vector into epsilon mu. So this is the term. So del cross B vector is equal to sigma mu into dou cross E vector is what? It is dou B by dou T. And similarly here also it becomes as what? Dou B by dou T. Sigma mu into minus dou B by dou T plus epsilon mu into dou by dou T of minus dou B vector by dou T. So in this term, del vector cross of del cross B is equal to minus sigma mu into dou B by dou T minus epsilon mu into dou square B by dou T square. So using the vector identity, here also we are splitting the terms in terms of magnetic field. When we split, it becomes del vector of del cross dot B vector minus del square B vector. So substitute the value of equation 11 in equation 10 instead of this term. So it becomes del vector of del vector dot B vector minus del square B vector is equal to minus sigma mu into dou B by dou T minus epsilon mu into dou square B vector by dou T square. Dou B del dot B அப்படிங்கிறது it is a dot product and it becomes as 0. That value will become as what? 0 minus del square B minus of this term. When we simplify this equation will change to del square B vector minus sigma mu dou B vector by dou T minus epsilon mu dou square B vector by dou T square. So this equation 14 represents the wave equation in terms of magnetic field in a homogeneous medium with rho is equal to 0. That is here the charge density is equal to 0.